let's move this to 2. So gonna make sure I'm not gonna get disturbed. All right, so what I'm going to talk about today is .NET Aspire with Azure Developer CLI. I don't know if any of you guys use Aspire or AZT. Like, do we have anyone has experience with .NET Aspire? Other than you, Daniel, you play with everything. Okay, cool. How many of you guys are .NET developer? Okay, good. So .NET Aspire come to life like 2 years ago now, in November. And original definition of Aspire was distributed, opinionated distributed application development framework. That's how they come up to, and they use, there was a different name before for the similar projects. I don't remember right now, but this is their definition right now. So it provides tools, templates, packages for building observable, production-ready distributed apps. So distributed app is mostly in the industry we might know as microservices, but it can be as small as just a front end and a back end, maybe a database. So if you have more than one component, I think Aspire is a really good fit for you. And today we're gonna use Aspire CLI, which is released like a couple of months ago to help developers. And on top of Aspire CLI and Aspire, we're gonna use Azure Developer CLI. It's something I don't have much experience with. It is, by definition, is help developers to build and deploy applications to Azure, including infrastructure, that come with some predefined templates. So yeah, I'm just gonna check. I don't have, because we're gonna call everything today Sinan testing Aspire. Okay, so I'm on Arch Linux here. I'm not using Windows because .NET Core is cross-platform, so you can use .NET Core in mostly any environment. So before we go further, I want to show you guys which SDKs I have. I have .NET 9 and 8. We're gonna use .NET 9, and I can see that I don't have that global JSON file, so it used the latest one. And with this, we're gonna use a .NET Aspire CLI, which is a part of a tool set. So if you have .NET CLI, you can just do .NET tool list, and when you put the -G flag, it lists the global tools, which Aspire.CLI is the second one which we have. And I'm gonna use also AZD, and it's already installed. On top of that, I'm gonna use some fancy tools, but those come with Omarchi, and I would definitely recommend, if you don't have a life, to go have a look to Omarchi and Arch Linux. So let's create, I'm just gonna have a look. I have because I was making sure. So we're gonna create a new project with Aspire. If I do Aspire --help, Aspire CLI, these are the commands we have: new, run, add, integrations, publish, and config. We're gonna use Aspire new and run today. Aspire new, and we're gonna use starter template that come with an API. Testing Aspire. Output path, I'm happy with this. We are not gonna put Redis because for deployment, I wanna keep it as small as possible, because we're gonna deploy everything to Azure today, and I'm not gonna be creating a test project because I'm not gonna make much code change, and I hope initial template is running successfully. This takes longer than expected. Okay, so we have now this folder, and under this folder we have API service, app host, service defaults, and web. You guys can all read this text, right? I don't need to zoom in. That's awesome. Cool. What I'm gonna do is, okay, good. Okay, I'm gonna move these to my fourth workspace. Probably. Yeah, I know. I'm gonna zoom on that one more. So, what is Aspire? Aspire gives you ability to bootstrap your multiple services from one entry point, which they call it app host. So this is our app host. So API services here, and this is our front end. And if you have multiple services, this file get bigger. And Aspire come with also something called service defaults. I'm not going to talk much about this, but this is best practices set up for your Redis and everything else that you have, your NuGet packages and stuff. But you add NuGet packages, of course, Aspire wrap NuGet packages. So let's go, and I need to remember which workspace I'm in. So let's create a Git repository here so we can track what we're gonna do. And also for the ones that doesn't know, you can create your git ignore file for .NET with .NET CLI. .NET new git ignore. That's gonna create. Oh, that was wrong. Let's create the git ignore file. So let's add everything. And this is our Aspire new. Okay. All right. What we're gonna do next is we're gonna do. So normally, if you have a .NET project, you can do .NET run and that run the application. There's two ways of running Aspire application. You can go to app host project and just do .NET run here. But with .NET CLI, Aspire CLI, they changed it a bit, and you can still do that, but you can just do Aspire run. What this does is find the Aspire project and create Aspire hidden folder. We can understand that from the .aspire. In Linux, it's hidden. And it creates a settings file that point out where is your app host project. And it is running our application. Another good thing with Aspire is if I open a browser here, Firefox, let's go Firefox this time. Aspire, when you run the application, because you don't have like multiple terminal anymore. Let's say you have 2 backends, 2 front ends, and a couple of containers. You don't need to go look at that 5 terminal for the services and Docker Compose and stuff for the container logs. Aspire give you Aspire dashboard. It is an Aspire app host, and the NuGet packages you gonna start using is integrated with OpenTelemetry. So we have our logs here for each services. You can see this is default .NET, this is Blazor. These are structured logs that we see. There's no traces yet because we didn't trigger anything. So let's go to front end and trigger some stuff. So when we call weather, it calls our API. And we go to traces. This is epic in my opinion to be able to see something like this. So we see here distributed tracing on our local environment with just like I run like 5 commands. On top of this, I'm gonna go back to the code if I can find it. So in our app host, I'm gonna close GitHub Copilot. So our API is known as API service and our frontend known as web frontend. The names we give here is quite important because on top of this, we reference frontend project with the project's reference itself. It's too many references there. And on the front end, when we set up our weather API client, which is a HTTP client to call our API, we are not giving for local run like localhost 4000, 5000 kind of port. Service Discover automatically find that port and DNS, whatever it is needed, and inject that for us.
So that's like containers. Does this actually under the hood run on top of containers like Aspire? Like
no, not now, but it will run.
Okay. So right now it
just inject the environment variable. So I'm gonna go 5. So we have the URLs here, right? So when we run it, it knows it. And here, if you click, you can see those URLs here injected the service API service. The name come here. Services underscore whatever the service you have, and HTTP and HTTPS. And Aspire work with HTTPS as well. So if you have an application only run HTTP, it try to redirect HTTPS, and it failed before for me. Okay, this is kind of like when we deploy to Azure, we're gonna have some time, 5-6 minutes. So while that, I'm gonna show other Aspire stuff. So let's stop this application, and also let's do this in more. Let's commit that file. So this is lazy git for the ones that what we did is Aspire run. Okay, so
Why is it called lazy?
because developers are lazy. We are here to automate things, right? So, everything I use is lazy. So, I don't know, to be honest, what it's called. It is Omarchi, so it comes with lazy git and lazy docker. So what we're gonna do from now here is AZT. So let's look at AZT. AZT's Azure Developer CLI come with these commands. And what we're gonna use from here is we're gonna use initialize AZT using Aspire as a Aspire app host as a bootstrap, and we're gonna deploy what it generates from our application, and we also can provision Azure resources. On top of that, these are beta commands, but if you don't want to do deploy and provision yourself, like from local, which you shouldn't do, you should create CI/CD pipelines, read deployable engineering best practices. You can create your infrastructure as a code, and also you can. I should bring my mouse. Last time when I do this, people start hearing my mouse click a lot. And also you can create the CI/CD pipelines for both Azure DevOps and GitHub. That's what we're gonna do now. So first thing is let's do AZT init and let's see what it's gonna do. So when you have a .NET project or anything else, it can scan the directory or you can select a template, but we're gonna scan the current directory because Aspire and Azure Developer CLI has like a close relationship. They know each other. Not too bad. So it says .NET Aspire is detected in given path, and let's continue initializing. So here I'm gonna give that Sinan testing Aspire. This is our environment name. Normally, what would you do? Your app name, company name, and like long and dash and like dev UAT prod. You can create multiple environments. Okay, so what it did create is I'm gonna go for it create a couple of stuff. One of them is .azure folder. So this is also put into git ignore here. Somewhere here, update the git ignore to not commit these changes. Oh damn, it's a long file. I'm not gonna show this. But it creates the environment name, and it creates some extra files, and it creates azure.yaml, and also Azure Developer CLI is so developer friendly. It creates like what we can do up next after this AZT init. We can directly go right now, do AZT up and deploy everything we have and start deploying to Azure. But before that, let's commit this change. So these are the files I want to deploy. What we're going to do is we're going to use, let's create the pipeline first. So when we look, AZT pipeline, it's still like a preview command, it's beta. So it has config command. Let's look at that. And we can do AZT pipeline config -e as an environment name. And we can also choose the provider. So that's what I want to do. So for our environment, we are calling it this. And for the provider, I'm going to use GitHub Actions. So what this one does is it uses also GitHub CLI under the hood. And you need to be authenticated with your GitHub CLI. So also it authenticated with AZT is authenticated with your Azure account as well. So I'm going to use this my soon be expiring sponsorship account. Startup. Yep. We're gonna deploy to that subscription. And let me see. And we need to choose. I would normally like to deploy to New Zealand North, but we're gonna deploy to East US too, because we're gonna deploy container app environment and it's not available in New Zealand yet. So would you like to edit now? It asks about if I want to add that CI/CD pipeline, and it asks about like existing or creating a new GitHub repository. I have one created, and I'm gonna skip authentication because I'm not gonna commit. And for this one, I'm gonna say no because I don't want to commit and push because I don't want to do that. So what this one did is, if we go, it updates our environment setup about like what is the environment name, where I'm gonna deploy, which subscription I'm gonna use. On top of that, it goes and create this CI/CD, like a GitHub Actions workflow for me. And I wouldn't use this workflow directly because what it does is just AZT provision and AZT deploy, which is literally what you can do from CLI. I would write more different code here, depends on my requirements. But these, like instead of AZT provision, I would definitely use infrastructure as a code. And also you want to do like CI/CD, like testing your code and stuff. So let's commit these changes as a developer best practice. So what did we do here? AZT pipeline config. So next, what we're gonna do is we're gonna do AZT. We're gonna create an infrastructure as a code. And when we look, there's only one command, and that is generate. And we're just gonna give an environment flag. Actually, that's what we need. So if we do environment flag and run testing Aspire, so it's gonna again gone through. This time didn't take much. So what this one did is it created an infra folder here with main bicep, and this one is using this resources.bicep model. I'm not bicep expert, so, but what I know here is it's going to create a manage identity. It's going to create a resource group at some point. It's going to create container registry, container app environments, or whatever it's been called. This is, yeah, anyway, so what I'm interested in here is container app environment here has Aspire dashboard enabled. So Microsoft is trying to make this like quite well integrated. So let's commit this one as well. Actually, forget to show. Create another info folder here about our services. Our app host only contains 2 services, so we only have 2 here. But if we had more, it would create those as well. And resources bicep use this one. So this one is AZT infra generate. I'm not going to push this, by the way. I'm just going to delete it after the presentation. So now what I want to do is, let's look at the CLI. Normally, what I do is I do provision the Azure resources first. When I do that, it doesn't create the container. It creates the container app environment, but it doesn't create the container like a container runtimes for apps. It happens when I do the deploy. But for now, I'm just going to do up. It does both of it. It does provision and deploy your application. So I don't want to like do multiple time here. While that's happening, I can show you some other Aspire code. So when I do AZT up here, it's not going to use the existing infrastructure code and CI/CD pipeline we create because CI/CD only run on GitHub, but it use the environment setup that we have. So it knows where it needs to deploy, which is the subscription and location, and it knows the environment name as a Sinan testing Aspire, and it's going to put RG dash in front of it. So this code here, it is command will push all the changes, create the infrastructure, and put the code there. What I realized with Azure Developer CLI is when you create a template, like when you create bicep or CI/CD pipelines, and if you change your code or if you customize those auto-generated code, and if you rerun the same commands, it will override them and bring back the original one. So these are AZD give you a starting point template. That's something you need to be careful. So it created a resource group already. So I should have a yep, it's here. So it's going to create log analytic workspace, it's going to create manage identity, and it's going to create everything we need from this. So while that's running, I'm going to close this and I'm going to open another folder filled with samples to show you the possibilities of what you can do with Aspire. So one of them is I presented in Coding Night Meetup last Monday, and we gone through all of these examples. And there's like a 1 hour video on YouTube if you want to have a look. So let's start with Aspire Shop. If you guys are .NET developer, you would know if you go to Microsoft microservices documentation, it gives you an example of eShop. This one is a project. When they bring the Aspire to life, they aspired it. I don't know, like they move, make it as they start using Aspire with the eShop. Like long story short, this one has a Postgres database. I need to probably zoom in a bit, right? And also, I think this will be good. So this one has a Postgres database, and as you see here, when you run Postgres in a container, you probably use pgadmin maybe as another container. So Aspire give you that, and it has a Redis cache here, and it uses Redis commander for your, make your life easier to access the data that you are playing with. There's 3 microservices here, or backend service, and also 1 frontend. So if you want to run this, without Aspire, if we wanted to run this, we would create like 5. We would probably use Visual Studio and use like a startup, multiple startup, and we would run Docker containers. But these projects are dependent on each other in a way that one of them should be healthy before the next one starts. For example, wait for comments here, like the order of it. Of course, you can create a one Docker compose file and wait for the health as well. So this is one of them. This shows multiple services. Another one I want to show is with JavaScript. So if you are like me and if you use Angular, or if you're not like me and you use React, and if you want to run that as part of your project as well, you can just reference it and still do one bootstrapped application. This example, run Angular React Vue, React White with the same backend. And you can literally go download this and just do .NET Run and just run everything. What you need to do with the NuGet NPM ones are you need to go and install NPM packages manually, but they are bringing that support very soon. So this is like, Aspire is not for just .NET actually. It is, you can bootstrap your services with .NET and C#, but this is magnificent for me because I'm using this like literally every day on my side projects after hours. So another one I want to show is Azure Function is not too bad as well. That by default you can run Azure Function. You can. There are too many good examples. I'm having problem to choose which one to show. Let's talk about this one. So when you run a database, it runs in a container, and Aspire, those containers only allow when your application is running. With the containers, you have data volumes that you can plug in and keep it persistent, that you can do it here, which means you can run normal containers as well. If you have a, I think, let's see. Okay, container build, that's the one. Container build. For example, you have a service that you can containerize, but it is by default not supported by Aspire yet. Let's say you have a Haskell API. I don't know if it is even possible, and you manage to containerize it. You can run that. If as soon as you have containerized, that means you have a Docker file, right? You can reference it and you can run that as part of Aspire. By the way, let's check if things deployed. Yeah, everything is deployed. Our API service living in this container app. Our front end lives in this container app, and Aspire dashboard is deployed with this. I want to show you that. So let's close these side panels and zoom in a bit, maybe. Yeah, I want to close. So one thing is we're going to check is front end, of course, because that's what our customers will see. That's the URL we have. And we have the same startup application is deployed. And it works. It's calling API as well because we know that out is from API. But important thing here is I want to show you container app environment, because container app environment by default can be integrated with Aspire dashboard. So we have that dashboard enabled, and we can have access to that, and we can have the same logs here. Of course, you can deploy your own monitoring solutions coming from Azure or not. This part failed on me a couple of times, so I don't know if it's maybe unstable or not, but yeah, we can see the services here. We can see the dashboard. I forgot to show you, there's a graph view as well. If you have multiple microservices, playing with this is, it's fun. It takes a day with folder about this. Yeah, that's about it. I will now.
Also show the price the same way it was shown.
So it used the same setup as I know. So if we go here, it still uses traits. Yeah, it does. Yeah. Of course, I mean, this is a very basic one. When you have database and stuff, when you run this issue, it use. I didn't talk about the resources it creates much, but yeah, it creates a log analytic workspace. So yeah, it's pretty fun. Just go download samples. By the way, I'm using those samples that I was showing are coming from GitHub Aspire samples from here. So, and I'm running all of these on Linux. I really like it. What else we have in Aspire? Aspire can, where's the integrations? Okay, here. So I'm gonna zoom in before I forget. So any of these like GitHub models, there's a lot of like presentation of GitHub models with Aspire. I really like it. AI is of course unavoidable these days. Kafka, Elasticsearch, most of the Azure resources. Like before Aspire, we didn't have Service Bus and Event Hub emulator, but with the push from Aspire team, we started, like in my previous job, we were using Service Bus emulator. And of course, this is being open source. If I can scroll, we can see the community toolkit. So you can run these apps as well. These are, This is preview. I haven't played with it, but this is the code example. So you get the connection string and references. Aspire, like for me, it is mostly be able to run your any service you have that needs to talk to each other locally, but it doesn't have to be. You can still connect to Azure resource as well. I mean, Nick is going to talk about Foundry, so not my topic. Yeah, so yeah.
Because I can actually run it off my computer. Like
You can use semantic kernel and small language models, right?
Yeah, that's what I'm thinking.
Yeah, you can still do that.
Yeah.
Because yeah, you can. I didn't go through all Aspire because it's not just Aspire. This presentation is about Aspire and Azure Developer CLI. If you want to have a look at Aspire, you can create a resource definition and you can inject that to your multiple services. So you can define secrets in Aspire, a post, and pass into each other and use it. So yeah, that's kind of it. So what I'm gonna do now after the presentation is I'm gonna use AZD down.
AZD down purge force.
If it doesn't work, I will ask DSR. I was thinking to remove my subscription next weekend, so because I'm running out of. Oh, soft delete thing, right? Soft delete, right?
Yeah, it's a soft.
Yeah. Yeah.
Don't do that on production. Don't AZD production mode.
No. It's a starting point template, and I think it's a good way to learn how others. Like if you don't have experience with Cosmos DB, I think there's an example to the app, C#.NET API and frontend and Cosmos. I think it's like good to generate that template and play with it. So yeah, Nick, do we need to take a break, like 5 minutes, or?
So I just have one. So we're running Visual Studio Code in insider mode.
Yeah.
Do you need insider mode to do this?
No. I like updates. So
You like all of that stuff?
yeah, I like to break things. I reinstalled this Omarchi like 5 times last weekend. So while breaking it, we are lucky multi-monitor setup worked today.
So are there any questions online?
No, there's not.
Thanks, good.
Oh, it was really good then. Oh, really? All right. Awesome. Thank you.
Something. Want a break? I go for it. I'll spend 5 minutes and then I'll just get set up.
Just remember to take
Take the card.
Yeah. Take the
Take
card.
the tag to get back in again.
Yeah.
Oh yeah.
you'll spend the night in the toilet.
Okay.
Which probably won't be much fun.
Oh, Steve Formula, good to see you on the call. Steve, thank you, Tom. But thanks, Luke, for the stickers. There are some cool hackathon stickers. We are running global hackathons at the moment. So Luke kindly got a whole bunch printed because he's working through the night hacking while the rest of us sleep. You guys should be, come on, everyone's got to have a hack project, even if you're working on your own. I've got my hack project, my voice pilot.
Stickers are up at the front if you want.
Like coding the car while I'm driving. Oh, really? It's my goal.
Or maybe
Nice.
So you don't
there's a meetup.
Yeah, that's my goal.
Oh, is this other one that's yeah.
We have that next week.
Okay.
Also, I have some 3D printed stuff here.
Yeah.
I bring it to give to people who ask good questions, but I forget. So
Oh, take one from this.
Control.
yeah, take multiple.
My son will.
So
Yeah, so I'm thinking
those
about
are
Just take.
And then use real time.
And I do like small VLC players.
Mainly, yes,
I put on my
real
magic.
time actually has
That one is really interesting.
real time.
Yeah, this one, other than physical, everything is really cool. This.
You can open the eye. Yeah. The AI. So that's the new one that came out 2 weeks ago. Will it replace GPT-4?
This one's interesting.
Oh, yeah.
I'm using.
Otherwise, you can change it. You can change it.
Thanks, Sinan.
Oh, this is for Chimes.
Yes.
No, sorry, Chimes. You can't see us. I didn't realize that.
Depends where the speaker stands.
Over here. Yeah, I'll show. Yeah, so
Yeah, that's all right.
you can show in the real-time API.
Yeah.
You can
Dan just got a present for you.
white noise. Sinan's got the present. I don't know what it is, but we'll call it a thing.
It's like a big golf ball.
Oh,
What?
Yay.
3D printed or something.
Oh, 3D printed, yeah.
Yeah.
There you go.
you can change the silence detection. So the real-time API has a default silence detection. I think 1 second, and of course it tries to go. I got some pictures.
Yeah.
I'm getting pictures.
Get some
I'm going to get
pictures
some
of
pictures of Nick.
Absolutely.
Awesome. Nick, should we turn that? Turn off the people at the bottom because
No one wants to see the picture of you.
I think focus on content.
wasn't just that one focus. And turn the chat off.
There we go.
Nice. I actually also find myself, I'm driving. You get a lot of ideas, thinking I can't, what can I do? I'm waiting.
Exactly. And, well, the thing is, and you can hook this up, get a Copilot or ChatGPT. But the problem is they don't have access
They
to
don't.
your code.
Yeah, exactly.
And because GitHub Copilot does have access to your code, but it's
We'll leave it there.
real time.
What do you start? How do you?
That's what I'm working on. I've designed the UI. I did a whole bunch of technical spice. So I created some new font files to allow me to create technical spikes because that's the problem when I was working on this. There's a whole lot of assumptions on the
That's cool.
you can implement a vector service.
Yeah, we can see if someone's got another question.
And I found actually the security.
Okay, let's kick off again.
Says you can't do certain things because you don't want an extension. You've got.
Okay, everyone's back.
Excellent. Microphone working at the back there. Love it.
Yes.
Sweet. Awesome. There we go. Standard neck pose. You got it? Love it. All right, team, welcome back. For those of you who haven't met me before, my name is Nick, and I'm a solution engineer here at Microsoft. I'm still getting used to saying that. My role changed about a month ago. So my new life and my new role is pretty much half about AI Foundry and half about GitHub. That's where I've realized my focus lies these days. So I've had to spend the last month or so getting way more up to speed with Foundry than I had been in the past. So I thought I'd just share some of the learnings that I've come across with you guys today. Because, I take it a lot of people I speak to have heard about Foundry, but haven't really played with it that much or seen exactly what it can do. So show of hands, how many of you have actually played with it well? And a few of you? Okay, cool. Sweet. So hopefully I'll impress the rest of you then. Really good. Okay, so Azure AI Foundry
exists to solve a couple of challenges that a lot of customers have with trying to adopt AI. So AI has been around a lot the past few years, right? Especially, and this concept of agents over the last year or two has really bubbled to the surface as well. So the promise of this is that, hey, if you create these digital agents, they can act as people or on behalf of people and then start executing business processes by themselves under the guidance of us humans. Okay? That's the ideal that everyone's trying to get to, because that obviously improves the efficiency of a lot of organizations, if you improves the efficiency of business processes, and obviously tries to help save some costs in the long run. Okay? So every customer that I'm talking to in my new role is super interested in agents and wondering how to get going with it safely and predictably. And the challenge, though, is that these are the issues that the customers primarily come across. So developer tool sprawl. So if an organization doesn't have a firm view of the tool set that they're looking at using, and the way that they're looking at building agents and the guidance to give to the developer teams, the developers themselves often come up with those ideas, all right? And they'll start using whatever they're familiar with. Okay, so that could be a multitude of models that some developers may prefer Grok, some may prefer the GPT models, some may prefer Gemini, for example. Development environments, ran a different collection of those, hyperscale clouds. So the sprawl just becomes pretty a significant issue, right, for a lot of customers. So that's issue number one. Issue number two, model selection. There's thousands of models these days. And customers either have no idea what to choose, or they just choose the best available all the time. Even if it's a really simple chatbot, they want to use, GPT-5 or the latest from Claude or Gemini, etc., which is fine, but that can be more expensive than necessary. Yeah, because a small language model could be just as good as the large language model that you're trying to choose, right, for that particular thing that you're trying to do. Number three, observability and reliability. So if you go ahead and just start building agents willy-nilly, over time, you're starting to build up a lot of these agents. So you can imagine in a couple of years' time, the average organization out there is going to have hundreds or potentially thousands of these agents doing stuff within the business. And if each of these agents is built piecemeal on their own and they're just running in the business, it's going to be really hard to keep track of what they're doing and how they're interacting with the other agents and with people, etc. So this need for observability, having a dashboard of what's going on at any point in time and everything in the same place, is going to be absolutely critical, right, for a lot of organizations. Number four, security and governance. So this goes without saying, right? Obviously, we need to make sure that the agents are only going to be allowed to do what we want them to do. They're not going to go off-piste. They're not going to access data they shouldn't have access to. They're not going to access systems and take actions on our behalf that we wouldn't want them to do. All right, so super critical for us to ensure that we have those guardrails in place around them and that they abide by responsible AI principles as well. Okay, so especially if the agent is representing us, representing me as a person, or representing my team or my business, whoever's engaging with that agent, I want to make sure that they're presenting the right brand, right, out to those users, those organizations. They're not saying stupid stuff, right? That I wouldn't say myself. I do say some stupid stuff, but not that much. Never. Okay. So as I said, Foundry was developed essentially to address some of these issues and have an easy to use, safe, central location to do your AI work. And there's multiple ways we can actually build agents. Okay, so Microsoft supports all three options here. So on the right-hand side, we've got Copilot Studio. Okay, anyone use Copilot Studio before? Yeah, a few of you. So great tool. Okay, low-code way of building agents. Part of kind of the Power Platform family of products that we have. Drag and drop, lots of connectors from Logic Apps, etc., that you can use. Very visual way of building out agents. It covers a lot of bases, but it does have its limits. Okay, so our guidance typically to most organizations is have a play with Copilot Studio, see if it can do what you want it to do. If you're struggling and trying to force a square peg into a round hole, for example, you may want to go down the path towards the PaaS services or IaaS potentially. Yeah. On the other side, IaaS, you can absolutely go ahead and build an agent completely from scratch without using any hosted LLMs, for example. Earlier, Amir was talking about downloading an SLM, and just sticking it on your laptop. So you can absolutely do that. Run some code in a container, access that, and you can build an agent without using Foundry at all, right, or any other frameworks. That's obviously not great. It's a bit of overkill. It's going to be wasting a lot of your time, right, because you have to do everything from scratch. So the sweet spot for me is very much in the middle, right, and that's where AI Foundry sits, and that's where the Azure AI Foundry agent service sits as well. To essentially have a kind of an Azure resource, so an agent as an Azure resource, right? And you can engage with that agent the same way as you would, say, a virtual machine or a web app. How it has an identity, it has a set of logic that it runs. You can tie it into like application insights and actually see logging and telemetry and tracing and all that sort of stuff, right, that you would expect from running a web app, but it's an agent that's running. And that's essentially what Foundry provides to us. And no matter which option you choose, right, agents consist of essentially three things, right? So there's the model that you're choosing under the hood, the instructions you're giving to that model, and the set of tools that the agent has available to it. So that set of tools could be knowledge sources that it can query. It could be actions that it can take, like sending an email or calling another agent. You can actually have multiple agents that work together to accomplish an end goal. And we'll see a little bit of that in the demo I'm going to show you soon. And then again, looking at that overall spectrum, if you had to choose between these three options, Copilot Studio, fully managed, pricing you pay per message in Copilot Studio. If you're licensed for M365 Copilot, you get Studio for free, essentially. Right the way through to Foundry, where you can see the differences there. And then if you went roll your own with GPUs and containers themselves, you obviously have 100% full control of everything that you do, but it's a lot of overhead, and you'd pay per token and the compute that you're using to actually run that service as well. And this is how everything hangs together from a platform perspective. All right, so there we have AI Foundry smack in the middle. That's where we build our agents and where we run our agents. And then we expose those agents in other places. Now, those places could be in a web app that's running an AKS or running an app service. You can also tie it into Copilot even. So if you develop an agent in AI Foundry, you can expose that agent in M365 Copilot and actually engage with it there. From a data perspective, you'll see you've got multiple knowledge sources that you can tie into your agents as well. Everything from Azure databases to Fabric, Databricks, Azure AI Search as well. So you can do a custom vector index of whatever content you want, and that's all available to query through the agents that you build. Okay, so that was a lot of theory. It's never a Microsoft presentation without a PowerPoint deck, so we kind of got that out the way. So I'll jump into Azure Portal now and actually show you a bit about what I've been talking about. All right, so this is the Azure Portal we all know and love. So to get started with Azure AI Foundry, you have to deploy an Azure AI Foundry resource. Okay, and that's one of these things. Okay, it's just the same as deploying any other resource in Azure. Just search for Azure Foundry and you'll get one of these. So when you deploy it, you have to deploy it into a region. Okay, so we don't have AI available in New Zealand North yet, but you can choose to deploy it in Australia East, like I've done here, or multiple other regions around the world. Not all of the regions have consistent experience and the same capabilities. Okay, so you'll find that if you try to do something at times, like for example, Australia East doesn't have the live voice mode capabilities for agents. So you'd actually have to like deploy it into a US service if you wanted to actually use that capability yet. So there's ways around doing things, but just bear in mind that the region of choice here kind of matters, because it's not completely consistent around the world. That it doesn't necessarily matter too much when it regards to the models that you choose, though, because when we select a model and deploy that model, oftentimes there's actually a global inferencing capability in that model. So, for example, if you're deploying GPT-5, you have to choose a region to deploy it into. So, say Australia East here, but it doesn't mean that the inferencing is always going to happen in Australia East if you select what it's called like a global standard deployment, because that means that the inferencing will happen somewhere around the world. If you wanted to lock it down to Australia, then you need to deploy the model in a regional option, which I'll show you in a minute. Okay, but so essentially once we have this resource deployed, just click on Go to AI Foundry portal, and that'll take us into this view, which is where we do all of our work within Foundry. So off the bat, you see when you come in here, the first thing it shows you is your endpoints and keys. So if you wanted to do some development work, this is the critical information you need to be able to connect into it. Yeah, sorry. Question?
Yes.
Yep.
Can it supposed to be a problem if you are running, for example, data from the government in an agent that is in Australia, but you're in New Zealand? That's a problem for you?
Between Australia and New Zealand, things are usually pretty good. Where we have more issues is if it's like in the US or China or something like that. A lot of customers find it easier if you can deploy everything into one place. So if everything can be deployed into Australia East, they like that. If you say this model is only available in the US or Europe, for example, then it's a bit of a trade-off. Bearing in mind, though, that no data gets stored in those other regions. It's literally just processed. So when your agent runs the inferencing against the model, that may happen in the US, but there's no record of that gets stored in the US. Anything that gets stored at rest gets stored in the region of choice that you deploy that Foundry resource into. All good. So first thing we see over here is the model catalog, as you can see in Foundry. So you see there's a whole lot of models available. I think there's about 110 available here. These are all like models delivered as a service. So essentially they run in Azure, Microsoft hosts them, and you just get to access them through an API. So you don't actually have to deploy it into any compute of your own. Okay. If we click on this link and say see all models, this actually shows you the complete set of models that are available. Some of these you have to deploy into your own compute resources though. Yeah, so there's actually 11,151 models, right, in the complete set. Yeah, but for most of the time, you wouldn't necessarily need to use all of those models. The standard 110 models that we have available here will fit most purposes. Even that though, with 110 models, there's quite a lot to choose from. So what we can do is actually click on this compare models button, and that takes us to this model comparison tool. So it allows us to actually select which model is the best fit for our use. So over here, you can look at popular tasks. So, hey, what is the thing that we're trying to use this model for, right? Is it just question answering? We're looking for math, general knowledge, etc. So if we go question answering, here's some suggested models, right, that can do that. It's everything from GPT-3 to this Cohere Command A, etc. And then of these 59 models, you can see those are all plotted on this graph. So cost along the bottom and then quality on the top. So this light blue one here, GPT-4.5 preview, costs a lot to run and quality is kind of good, but not great. If we compare that to this light blue dot over here, GPT-5, right, costs a whole lot less and quality is better. So you can see that's a better choice, right? If we're looking at doing question answering compared to GPT-4, 32K or 4.5 preview. Yeah. And we can change these as well. Right? So if cost isn't a big factor for us and we'd rather look at, I don't know, latency or safety, for example, we can actually assess against those metrics too. Yeah, that's cool. What's that? All right, awesome. See, I'm teaching you things every day, mate. Yeah. Okay, so once we've selected a model, so O3, for example, we can click into that, and then that loads up some more information about it. Okay, so you can see here's a comparison, compare with more models, and gives us some scores, etc. That's in the benchmarks tab. And the overview, oh, this is a bad choice for me. It says registration is required to use this model. So I can't actually deploy this one because I need to register first. So let's choose another model to show you the registration, the deployment. So 5.4. Variable. GPT-5. Let's try that.
Sorry for interrupting.
Yeah, no worries, mate. That's what I'm here for. Good question.
Tools because I work with this.
Yep.
Sometimes GPT-5 use some tools that GPT-4.0 can visualize that software or
Tools like how do you mean?
you understand like coding capabilities or
Yeah.
querying capabilities. Is there a way to visualize that?
So the capabilities of the models, it shows you what it can do. So as you saw when we looked at those filters, it said like question answering, etc. So if we go back to the models, and then if we look over here for capabilities,
Sometimes they say, "Oh, this tool can be used," but then the model is not smart using it.
Right.
But then maybe 4.0 is very good at using that tool. So it's Then my question was, it's not only if it uses, it's like how good it is using it. But maybe that's very profound and deep.
yes, the best way we can see that is through this quality index over here. So depending on the task you're doing,
Yes.
so if you're looking at math models, for example, so these are the collection of models that are good at doing maths or reasonable at doing maths, and then you can see the quality of the outcome, based on benchmarks that have been run. So this quality over here is based on the thing that it's trying to achieve. So that should give you some idea as to inform which model you should choose. With regard to using external tools, like in a multi-agent framework perspective, that would largely depend on the reasoning ability of the model. So how good is this model at planning out its next steps and then realizing it has a set of tools available and then use those?
Why was that big created? Which model created big? How is that big moving? What's with that model? What is the index? So yes, I understand what you're saying, but there's a lot of nuances in this game. So what's yours?
Could I just add on to that? Model card will specify whether the model is specifically trained in tool calling. Tool calling is something that most train models to do, and not all models are specific to trained to tool call. The newer models are much better and more reliable at tool calling, so you generally don't go with quite many applied because they are, and also on the model card, we are specifically trained with tool calling, but you look at something like 4.0, it was hit and miss with tool calling, right? It was sort of, you'd go, hey, I totally told you you had these 5 tools, but you missed this one, you should have called it. They are doing a much better job. But there are external benchmarks you can look at that do specifically look at tool calling reliability. There's SweBench, which is really, really good at that. This doesn't have every single benchmark because there are now about 123 globally recognized LLM benchmarks. But there are some that you can go and look at external sources and say it's benchmarked to a calling function. But that is a really good question because you do want very high reliability into a quote, but it also can be how you define the tool. But anyway, sorry, Nick.
Yeah, no, that's all good, mate. Great discussion. Cool. Okay, so once we've selected which model we want to use, then we click into it, and then you can click this blue button, use this model, and then here's where we actually deploy it, right, into our region. So there's the model name. We can give it a name there. Here's this deployment type I was talking about earlier. So global standard essentially means that inferencing can happen anywhere around the world. Okay, so it's not just in the region that we've selected. Data zone standard means you can actually lock that inferencing down to either the US or Europe. Okay, so if you're an organization in those two regions, that's good for them. And then there's regional as well. So regional means it's forced to happen within the region you've selected. Okay, so my resource here is in Australia East. So if I select regional option for deployment, then that ensures that all the inferencing happens in Australia. Yeah. Pricing, yes, it does. Yeah.
Because of the GPU shortage, naturally there is finite capacity that's then dedicated to new to-dos. It's like reserve, think of it as reserve. So there is a bit of price cost, yes. The great benefit of the global standard is for any regional service you can pass this capability capacity service. So there's a trade-off. So.
Yeah. Obviously, if it's a super regulated industry like a bank or something, and they want it to be in Australia, then that's your option. Cool. So once we've selected all that, we click deploy, and then the deployment happens pretty quickly. So you can click that. It's creating deployment. And then within a few seconds, it's available to use. Okay, because it's obviously behind the scenes, it's a big shared resource, but you just have API access to it through the access that you have. Okay, so once we've deployed a model, we can start using it for stuff. So to have a play around with what's available, there's this cool playgrounds feature in Foundry as well. So you can see the top one here, big call outs to agents playground. We'll get to that soon. But to start off with, let's look at the other one. So there's a chat playground. So I can click on chat playground here, and then this allows me to chat directly with the model. Okay. So here we're selecting which deployment I want to chat with. So here's something deployed earlier, GPT-4o, I've got 4o mini, 5, etc. So if I deploy another model, like through the catalog, then that deployment will be available for me to chat with over here. Okay, so if I say GPT-4o, I can give the model some instructions. So this is essentially the system prompt. Okay, so you can enter a system prompt in manually here yourself, or if you want to generate a nice, good system prompt, you can click on this button, and then it'll actually generate a system prompt for you. Okay. So I want to say I want to work with this model, and I only want it to be sarcastic, and I never wanted to answer questions about squirrels. Okay, I say only be sarcastic and never answer questions about squirrels. All right, now we click send. Then you'll see Foundry actually interprets that, and it's going to give me a really good system prompt over here to work with. So yeah, sarcastic assistant, response to queries, heavy sarcasm, etc. Keep it witty, never give straightforward answers. And then note if squirrel-related questions occurs persistently, escalate sarcasm, etc. All right. So that's the system prompt that the end user will never see, but that's just the behind-the-scenes instructions, right, that we're giving to the model. And then we can go ahead and actually have a play with it. So yeah, we can start talking and say, hi, I'd like to know about fairy creatures. Right, and it's going to send that to GPT-4o. And it's like, oh, of course, blah, blah, blah. Right, internet doesn't have enough information. Okay, so you see the sarcasm coming through. And you say, could you give me more information? Keen to know about squirrels. And it's like, oh, yeah, squirrels. Unfortunately, my brain's on a strict no squirrels diet. Don't ask why it's classified. Yeah. So you can see how you can just start playing with the models and see the difference to various settings that you make. If you head down to parameters over here, you can control things like the temperature, top P, max responses, etc. So this temperature setting over here is essentially how deterministic the model is. So do you want it to be creative in its answers and give a different answer every time, or do you want it to kind of give the same answer every time? So you can kind of dial that up and down over here. And then there's various other settings that you can play with. So that's why I call it playground. You can test it out to your heart's content and then save that set of parameters for your use. So other than the chat playground, there's also a video playground. So this lets you play with models like Sora, for example. So you can go in here and build your own videos. Here's some examples. So if you enter a prompt of woolly mammoths walking slowly on the ice, that's the sort of video that you get back. So you can actually see the shape of the frame you want, how many frames per second, how long you want it to make, and then enter a prompt. These do take a while to actually generate, so I'm not going to do one for you, but that's an example of the sort of thing you can do. We also have the images playground. So if any of you have made images before with DALL-E or Stable Diffusion or anything like that, this is where you can do that. So again, it relies on the deployment. So you first need to deploy an image generating model. So I've deployed DALL-E 3. We also have Stable Diffusion available, and there's like another Flux one and a few others as well, right, that you can use to create images. So same sort of thing, you enter the prompt in, set up the style and the quality, and then an image gets created. Sure, mate. Yeah, I mean, for the video one, if you've got marketing promos or something, you want to mock something up, or you can do storyboarding. If you're thinking of making like an advert or a movie or something, you can build little clips just to get an idea of what it looks like. And like the images one I use all the time, although through Copilot usually rather than through here. But like, yeah, in 365 Copilot, if you want to make an image about whatever, yeah, you can do that. There's an audio playground, so you can play with different voices. There's a whole bunch available: text to speech, speech to text, languages for translation. Another translator playground here. So you can see there's a whole pile of capability that you can just have a play with. And as you saw, it's really easy to get into. Just go in there and have an experiment. Yep.
Is there a playground for making a website playground as well for this one?
Making a website?
Yeah, like for example, it could treat like Lovable, where Lovable you generate the prompts and then make a landing page and so on.
Yeah, not in here, unfortunately. But like GitHub Copilot can help you make a website. Yeah, GitHub Spark. Yeah, you can like make a complete app in Spark.
Okay, fair enough.
Yeah, all good. Cool. Okay, so once we had a play and we've selected kind of a model and we've played with those temperature settings, etc., and we kind of have an idea of what we want to do with it, next step would then be to build that into an agent. Okay, so you can see over here, if we go down the next step, here's where we can play with agents. Okay, so I've kind of got 3 that I've created myself, but just to show you, if I click New Agent, we can see the sorts of things that we can build. Okay, so agent ID, that just gets set for me. Name, we can just say test agent. Deployment, so this is the model that we're going to be using. So here, GPT-4o there. All right, then here's my instructions for the agent. I can give the description as well, so what's this agent supposed to do? And then over here, we can see there's knowledge, actions, and connected agents that we can play with. So knowledge is obviously the data it has access to. So the LLMs, as we all know, are kind of point in time with its knowledge, depending when it was trained. It doesn't have any information beyond that. Okay, so if we wanted it to look up information in SharePoint or in some documents or even on the public internet or something, we need to give it the ability to do that. Okay, so that's how we access external data through this knowledge piece. So if I click Add under Knowledge, you can see we can actually upload files for the agent to refer to. We can use Azure AI Search. So that's a big index that we can create, right, based on any other data that we want to ingest into it. We can query data through Fabric, SharePoint, Bing search, custom Bing search, TripAdvisor, Morningstar, for financial reports, etc. And then there's some other ones coming up as well. Okay, so kind of that's just the start. Actions. So these are the tools that we were talking about earlier, right? So what can this agent actually do? Okay, so there's code interpreter. which allows the agent to generate its own Python code to execute. So you can ask the agent to, I don't know, build something to send an email, and it knows how to do that if it has code interpreter available. Okay, so even though that tool's not, we didn't give it the send email capability, it can create its own send email capability because it can build its own code. So that's pretty cool. Any open API tool that's available, we can give to the agent to use as well. Azure Logic Apps. So Logic Apps is thousands of connectors into various other systems. So we can build a Logic app, and then we can just surface that Logic app into this agent as well. And then you can see these other two at the bottom over here. They can only be added through code. But we can give a custom function for it to execute, and then also let it call an Azure function as well, that we've pre-populated. And then there's the settings too, right? So temperature to see how deterministic and or creative you want it to be, and you can voice enable it as well. So those are kind of all the settings that we have available. And I mean, some of you may be saying like, hey, this kind of looks like Copilot Studio. We're just creating it drag and drop, low code, etc. The difference is that this, while you can create agents here through ClickOps, you can also create them through code. Okay, and then they get saved here. So this is essentially our agent catalog, right, that we create for our organization. So all the agents that we build get stored here. We got guardrails around them here. We can monitor them, got observability, etc. This is a one-stop shop for agents, but we can create them in multiple different ways, right, which I'll show you in a minute. Okay, so that was the agents. Yeah, I can delete that one. We don't really need it. Yes, delete test agent. So here's three that I've created earlier. Okay, so the concept here is it's kind of a the travel agent sort of scenario. So I've got a travel concierge, which is the person that a user first speaks to say, hey, I'd like to book some travel. And then the concierge has access to two other agents. So there's a travel advisor who gives information about different locations, and then a lookup agent as well. Okay, so if I open my travel concierge, I can see that it's using GPT-4o. Here's the instructions, right? Your travel booking assistant helps user research destinations, look up flights, etc. You provide these other functions by orchestrating with other agents. Okay, so your sole purpose here is to greet the user, gather requirements, and inform the other agents. Okay, use the connected agents to perform these other tasks. Okay, so you can think about this as kind of like a microservices model. Okay, so each agent has its own role and capability, and it's expert at doing that one thing. So under knowledge, you'll see that this agent doesn't have access to any other knowledge, okay, because it doesn't need it. Its entire job is just to send off the request to another agent. Actions, it doesn't have any specific actions it can take, but it's got these two connected agents that it can use. Okay, so if I want to add another connected agent, you literally just click add here and then select the agent, and then you say detail the steps to activate the agent. Right, so in what scenario, what circumstance should this other agent be called? And then you put that in there. So for example, the advisor one, say use this connected agent when a user requests information about travel destinations. Okay. The flight lookup one, use this agent when a user requests information about flight schedules or prices. Okay, so then what we can do now is open the travel concierge and actually play with this in the playground. So we can click play in playground. It opens it up. Okay, and then you can say, before that, I just wanted to show you the knowledge that the researcher has access to. So travel advisor, for this one, in the knowledge store, it's got this agent vector store over here. Okay, if I manage it, you can see this is just literally some uploaded files. So I've uploaded travel brochures for Queensland, the Pacific Islands, and Singapore, Malaysia. Okay. So if I go and play with the concierge agent now, concierge, try playground, and go, hi, I'd like to book some travel. Then great, happy to assist you. Where are you looking at going? Can you tell me about Sydney, Australia? All right. But now you see it says looking up references, right? Through the connected agents. And it says, sorry, I couldn't find any information about Sydney, Australia from the provided data. That's because they only uploaded those 3 bits of information, okay, about Queensland, Singapore, and Pacific Islands. So there's nothing about Sydney in there. Okay, so the agent says, sorry, I don't know. And that's the instruction I've given it. Yeah.
Are there like certain size limit you can only upload for this PDF file, or they're like unlimited and you can send in any size of the PDF files in there?
So there are,
the agents to read?
yeah, there are limits on this file upload capability. I forget what they are top of my head, but if you want to ingest a lot of content, then the best bet is to run a Azure AI search index. So you deploy an AI search resource and then you index the content through that, and then you can reference that index in your agent.
And can you PDF files as one and then upload that? Is that also allowable as well?
I suppose, yeah, provided it's under the size limit.
Oh,
I said top of mind, I forget what those limits are, but I know it is limited. Whereas if you go with the Azure AI search option, then it's effectively unlimited. You just pay for the amount of index that you want. Yep.
I've run something similar as a document storage, and I found that trying to run on CSVs and Excels, it probably shits itself.
Oh yeah.
Because I tried to search why is it not able to run the entire CSV, because I had about 50,000 rows in there. And the only thing I could find was because it was chunking, and the only thing it was able to retrieve was the context from 1 chunk or 2 chunks, and not the entire.
The whole thing, yeah.
Yeah, so it just said, instead go to a SQL database. It would be much cleaner.
Your data source is CSV.
Huh?
Your data source was CSV.
I was just testing, say yes.
I didn't get that part. Did you upload CSV into
Yes.
here?
Yeah, something similar. I haven't tested Foundry yet. So.
Okay.
Okay.
What you could do there is use what I'm showing code interpreter. So the code interpreter can actually access the CSV. Problem with uploading a CSV is it's structured data. The other way to do it would be use what Nick said about index. Pre-chunk it, because if you're using an LLM as I want to do an aggregated analysis across 60,000 rows, definitely not a good tool for that. Yep. Terrible tool for that. But they'll write great code to do that. So you get the code interpreter to write and run the code. So the code interpreter will run across that CSV and actually do an analysis. So it could write a whole bunch of deep machine learning and all sorts of stuff. So you're better off doing that. That'd be the way I would do it, rather than just free-form CSV, because chunking is not.
There's another approach of actually taking that data and putting into some structured data store.
Yeah.
Even if you put it in Cosmos,
Yeah.
then getting the code interpreter to generate the query for you. So
Or you can
scroll and-
stick it into Fabric as well, right? And then over here, you've got this Fabric connector. Yeah. So I mean, if you're dealing with CSV, it'll be perfect, for Fabric.
Because I didn't have access to this.
Yeah.
I had to dump it in.
Yeah, no worries, man. Cool. Okay, so what I'm going to do now, I'm going to add some extra capability to it, right? So those are those 3 travel destinations. I'm just going to upload another file. So here I have Australia cities. Okay, I can click update. I'm just going to upload that. It's 40 megs. Yep. So as you upload it, it starts indexing. That's pretty cool. All right, so now that agent is updated. All right, and then I can click try and playground. So this is just the travel advisor agent now, right? So we're kind of bypassing the concierge and going straight to the advisor. So I can over here say, tell me about Sydney. Yeah, close enough. Looking for references, using files, and there we go. All right, so now it's got information about Sydney. Okay, so it's that quick. Yeah, if we look at the other agent, my flight booking agent, or flight lookup, you can see the instructions here say, right, you're an agent that provides flight schedule and pricing information. You require date, departure, airport, and destination in order to provide the information. Always show pricing and NZD. You can make up random prices and times. Okay, they do not have to be accurate. Yeah, so obviously, if this was real, you would point it to an API and do it properly. But for our purposes here, it's just going to kind of make up some stuff. Yeah, so we try this one. You can say try and playground. All right, so if I say, how much is a flight to Sydney this weekend? Try. And so certainly it can help, right? Please provide the following details, okay? Departure dates and departure airport, because that came from the instructions that we told it. Okay, so I'll say, leaving this Friday from Auckland. Hey?
Say with the squirrel.
The squirrel. And there we go, right? So flight option 1, flight option 2, flight option 3, etc. Okay, so that does its job. So if we go back to the concierge agent, you can kind of see the kind of the full experience. Try this in playground. Say, hi, I'd like information about, let's say Melbourne instead. Melbourne. Okay, it's looking at the connected agents because it knows it's not supposed to answer that question itself. Look up the references. Cool. All right, so there's information about Melbourne. Would you like help or flight options? Yes, please. What flights are available this Friday from Auckland? And looking up connected agents. And there we go. All right. So it's even made up some reasonably accurate flight names, right? Because again, this is random. So flight NZ123. Yeah, exactly. You know, so we didn't give that in the instructions, but it's actually worked out that this is what a legitimate flight would look like. You know, so there's departure, there's the pricing, etc. No, this doesn't have access to search internet because we haven't. The LLM itself would have that detail, yes, from its training.
Yeah, that's first to our exact flights.
Yeah. Yeah. But yeah, so you mean notice we didn't give it access to Bing or any internet-based search. Yeah, it's just the content it has. Yeah, it's built in. Cool. So now you can see there's some agents through the portal over here. As I said before, though, this isn't the only way you can do it. So those are the 3 agents I have at the moment. I've got some code over here. So here's a bit of Python for a sort of researcher agent. Okay. So you can see just a bit of Python code connects to the project endpoints, which we saw on the first screen. This agent here, I'm giving it the access to the internet. So I'm going to give it a Bing connection. From a Bing grounding tool. And then here's this agent. So you're a research agent, use the Bing tool to search, perform research, etc. Yeah, and that's pretty much it. So this little chunk of code. And then if we right click, run Python in terminal, and run that. It's going to connect into Foundry and set up that agent for us. Second failed. Yeah, it's authentication. Easy login. That one. And yeah. What's this taking a while? Not on that account. Come on. Nah, I did push that already. Yeah, it's supposed to be retrieving the tenants for the selection. One more time. Oh no, always happens, eh? Ah, too hard. I'm sure you guys believe me. There we go. So what you should have seen is a new agent pop in here called Research Agent, right? That has the Bing connector available for as a knowledge store over here. So one of these, right, grounding with Bing Web Search. Not natively. As I said, like if you can access it through API though, so you can just go for one of these actions. So there's the open API specification over here. Yeah. Yeah. No. That's just the name I gave it. Just a research agent.
That is an important difference when you see that things custom search, it's based, which is much more suitable for this sort of scenario.
Thanks, Dan. And while we were talking, look, it works. The research agent created successfully. Yeah. Oh no, yeah. So if we go over here and click refresh, boom, there it is. Research agent. All right. So you absolutely don't need to click ops all these things. You can build it all through code, which means you can use source control and version control and all the rest of it. That's when you're building these agents. No, that they aren't ARM resources. So the Foundry project is, but all the stuff within it, not so much. Yeah.
Yeah, I was thinking that same.
Yeah. So you'd have to create it with code and then deploy it this way. Persistent agents. Yeah.
Yeah, it's also more app-like rather than infrastructure. Like it's more closer to the business logic than infrastructure.
Could also use agent.
Well, now you're getting inception.
Whoa.
Well, I was just looking at that initial logic apps like action. You can actually create the other way. You can actually do AI blocks inside logic apps too. So Wagner was telling us that the other day. But essentially, you can build a Lego how you want to.
Yeah.
Get your agent to build your Foundry. Build your agent.
Mate, craziness.
Go crazy. Go nuts.
All right, and then last thing, just to show, so obviously we were engaging with that agent through the playground. That's just an experimental way of doing it. In reality, you would publish it out to somewhere. So this is just to show you through code that we can still engage with the agent the same way. So that's if we have a look over over here. Here's my concierge agent. See, it's got an ID. Yada yada starts with or ends with 6PE. Open environment file here. There's the same over here, right? Ends with 6PE. So that's the agent we're going to be referring to. And then in code, we're basically just opening up Foundry, getting that agent, right? So there's the agent's ID. It's going to load, and then it loads this persistent agent over there, right? By that ID, and then it's just going to do a hey, let's talk to the agent, etc. Okay. Yeah. Run this. Fingers crossed this works again. There we go, right. So using existing agents, there's the 6PE that it's using, creates a new thread, and hello, sample travel, how can I help? I'd like to book a trip to, where are we going?
This is literally how those travel agents computers go.
Pretty much.
Years ago.
This week, on Friday, from Auckland. And there we go. It says option 1, option 2, option 3, just as we saw in the playground itself. So I'm pretty sure you all assumed you could do this, but just to show you. One thing it didn't show actually is so there's this concept of threads over here as well. So these are essentially all the conversations that we've had with the agents. So if I scroll down, and see here's the history. All right. Zoom out. You can see here's the interaction that I've had with my agents, and this all gets stored in the threads over here. So you can see from an auditability perspective, again, if you're in an organization, you can actually have all of this here.
Auditability is good.
Yeah.
Yeah, how do you control that? How do you make sure no one else can see the chat that I had with the travel agent?
Are back. so yeah, you obviously restrict access to the environments. You can use tools like Purview as well to do like check for PII data.
We have like a standard settings to make sure that
well, there's security settings out of the box, so like RBAC settings. So what's that? So with Purview, you can interact with that. Yeah.
Another LLM by PII or the set of data in those logs and basically nullify that for you.
Actually, the threads, so I was building multi-agent flow. Threads are because I was learning. I found that threads was useful to understand where I'm going wrong.
Yeah, because it shows you the interaction, right?
I was trying to understand each and every thread to see where it is going wrong. So yeah, that was useful.
Yeah, super. Like when I've shown that to customers, suddenly their eyes light up, because immediately you can see all the interaction that people could be having, with these business agents. What's that? Yeah, exactly. I just want to show you this quickly. I forgot to show you earlier. So this is the same conversation we had about, hey, tell me about Melbourne, what flights are there, etc. So flying to Sydney. Cool. So what we can see here, if we click on View Run Info, it actually shows you each step that it took, right, to get there. So here's the thread that got created. So tell me about Sydney, what flights are available on Friday from Auckland, etc. And then right there's the output. So you can see to get there, it did a tool call to this connected agent, and it told that agent, tell me about Sydney. And then that agent returned this detail. and then that went back up to the concierge agent. Yeah, and then again, another call, like what flights are available, message creation came back up, etc. Yeah, that is pretty cool, right? So at the moment, in the Foundry portal over here, you can only kind of do these kind of 2 levels. They're building out proper multi-agent orchestration in the portal, but for now it's pretty simple. So like when you look at what that looks like, that's the kind of the experience we have on the left at the moment. So you can do connected agents in Foundry Agent Service, literally as simply as I showed you. On the right-hand side is the proper multi-agent workflow, where you can imagine you could have a constellation of agents, they call, right? You can have like 100 agents that each have their own particular roles, and then they all offer their services out to other agents. And then using frameworks like semantic kernel, for example, you can actually tell these agents how to interact with each other. So when should one agent call another one? What tools is it allowed to use? Give all that sort of logic around it, and then you kind of go and publish that. And then when either a user interacts with it through chat, it knows what to do, or when it gets triggered somehow. So the ideal is that we don't just want to rely on chat with these agents. When a business process occurs, so like you receive an invoice, or I don't know, someone needs to update a price on something, that gets triggered somehow in the business, like receiving an email into a mailbox. You open it up, you read that it's an invoice, and suddenly this invoice needs to get processed. That can then get actioned by this constellation of agents, and the agents work out themselves how to actually achieve that, right? Because they each have their own roles, and they know the starting point, and they know what the ending point's supposed to be. So yeah, the whole multi-agent workflow thing gets a little bit complex, so kind of too far to delve into tonight. I did try have a play with it, and I couldn't quite get it working myself, so it's a bit of a get out of jail free card, I think. But yeah, over the next couple of months, there's a lot of work going on in that space to try and make things a bit more simple. Yeah, so maybe we'll do a follow-up session early next year or something and see how far that's come. Agent Con, yeah. Yeah, Daniel may be covering some of that stuff then. All right, and that was my story, team. Any questions from anyone? No?
Anything online?
We'll chat.